Hey, Bryce Carlin's here, Robot Competition News at 2017 Worlds in Houston. I'm here joined at the practice field actually by 2073. They just finished testing a couple mechanisms and features. And I really want to talk to you guys about kind of your process and how you develop your strategy and how that relates to your robot design.
So how it begins is in the beginning of the season, we figure out what we want to do, and after that we figure out which mechanisms we'd like to make. So to begin with, we decided that we wanted to pick up gears off the floor because it allows the strategy of taking gears from opponents who drop them. So after that we developed our floor intake, which is our robot. Now that's gone through many revisions over the time. For example, at Utah, it was a much different intake, but we found out the balls could jam in it. So we took it back and we used part of our 30 pounds to change it into a more refined model that allows for easier picking up. In addition, we create two robots. That way, after the season ends, we can still work on our robot, figure out our autonomous routines, and test new mechanisms without having to worry about not being proven. Therefore, during the build season, we build a practice bot, which we make all of our mistakes on, and after we learn those mistakes, we use the last week or two to build the main bot. That way it's ready for the bag, and the build quality is much better, and it's ready for competition.
Very interesting. Yeah, like building two robots, like having practice bots, definitely like a strategy I've seen used a lot. And with using them with holding limits to your advantage, is like with the holding limits there for a reason. Definitely, they want you to make improvements throughout the season. They wants you to make changes, see what works, see what doesn't. Run me through a little bit, like on a week-to-week basis, kind of like how your build season lays out.
Well, the first few days are, of course, reading the rules, figuring out what we want to do. And after that, the next week or so, or half week, is prototyping mechanisms and deciding which ones we want to use. The week after that's CADing, so now we're around week 2.5, week 3. The next 2 weeks are for making the practice bot, because it takes a lot longer to make your first bot, because you don't know what the design challenges you're going to run into are. After you figure out what you want to change, you change it in the CAD, and you create your main bot, and after the season ends, that's when you go back and catch up your practice bot to the quality of your main bot.
Gotcha. Very cool. Yeah, the kind of process is really like the process of like throughout the season scheduling. I think is what a lot of teams like kind of struggle with. That's like what really kind of brings teams up is just how good they can optimize time. A 6-week build season is so tight. Time optimization is the biggest part, I think. So Jason, you worked on a bit of the programming side and a little bit of the sensor stuff. So if you could talk to me a little bit. You said you use a lot of different sensors on robots here.
So in our autonomous, we use a lot of gyro, which keeps our bot moving straight. So if any balls, other robots hit us, we can keep moving straight. Make sure we're a very consistent autonomous. Always center peg, turn and shoot, and we're there at every match. In addition, with our gear intake, we have a light sensor, which when we intake a gear sends a vibration through our program. So we vibrate the controls for our pilot and co-pilot. So as soon as we pick up a gear, even if they have no vision of the bot, they immediately know, okay, we have a gear, we're ready we can come back, put it on a peg, and there's no communication between them because both their controls shake as well.
Gotcha.
So that's helped us a lot in the matches.
That's very cool. We've made a lot of jokes about using the rumble on our controllers before, but we never really found a good way to utilize it. That's a really good idea. Because I know it's definitely difficult if you're like trying to take gear on the opposite side of your robot. Knowing when it's in a floor intake is almost the hardest thing. Very, very cool stuff. Anything else you guys want to hit a little bit about your like specific features on your robot, cool mechanisms you did?
We are running PID control for both our gear intake and our ball.
Oh, okay.
And it allows us to maintain a consistent speed using the rotary encoders that we have employed within our gearboxes. And after that, the feedback allows. Well, Jason will tell you more about this.
Yeah, so we use the PID controls. We use a modified version of PID called FPID for our shooter, and we also use proportional gain, which is a segment of PID for our gyro within autonomous, and we use it in teleop as well. And that just allows us to stay consistent because any basically what it does is if let's say we're 2 angles off to the right, it compensates for that, and we'll subtract that from the other side and then correct it, and then it'll keep going back and forth, making sure we stay straight.
And you do that with gyro or encoder?
We use it with the gyro.
Okay. So you said you had PID control in your gear intake, your floor gear intake. Is that for the rotation aspect of it?
Yeah, we want to make sure that we're always flush with the floor, and we want to make sure that when we pull up a gear, it has to be at the right angle to put back on a peg. Otherwise, we're going to be missing, smashing pegs, bending them, and then they're useless for the rest of the match. So
Gotcha.
It's really important to keep that consistent.
Very cool stuff. Awesome. Thank you guys.
Thank you.